Students, very good evening. This is Mayur S. More, your chemistry tutor, as you all know. So I welcome you all to NEET Chemistry session number 5. Now this is session number 5 for IUPAC nomenclature. We are covering a IUPAC nomenclature in this NEET Chemistry session. Okay, we had seen many of the rules. Okay, we had seen the rules which are applicable to rings, then to alkane, alkenes, alkynes. Okay, and today, hi Pavitra, hi, very good evening, beta. And today we're gonna take our discussion forward. We're gonna see how this IUPAC nomenclature is applicable for functional groups, because functional groups nomenclature is most important. There had been so many questions been asked on that in the previous year exams. Okay, so we're gonna see that today. Chalo, let's move. Let's start that. I welcome you all to NEET Chemistry. Let's begin. What are some of the functional groups? See, there are two types of functional group. Before moving to that, let me tell you what is mean by functional group. Firstly, functional group we had seen in GOC, in general organic chemistry, that what are your functional groups? Alkane, alkene, alkyne, if, and aromatic hydrocarbon, for example, benzene. If you don't consider them, functional groups are the groups which imparts a certain property to organic compounds. And those functional groups generally contains either carbon, nitrogen, oxygen, sorry, carbon can be there obviously, but mainly they have a nitrogen, oxygen, phosphorus, sulfur, or halogen. So these atoms, if they are present, maybe along with carbon or maybe not along with carbon, then those kind of groups are called as functional groups. Those functional groups imparts a specific, or I would say, characteristic property to your organic compound. Okay. So now on that note, let's see what are those functional groups. See, there are two types of functional groups. One is non-chain terminating, another is chain terminating. Now, chain terminating means what? These functional groups, they are present. This functional group, they are present only, they are present only at the end of the chain. They are present only at the end of the chain. This is the point that you need to understand. They are always present at the end of the chain. Okay. And non-chain terminating, these functional groups, they can be, I would say, not can be, in fact, I would rather say they may be or may not be. They may be or may not be present at the end of chain. That means they can be present at the end of the chain or they can be, at the middle of the chain. No problem with that. But these functional groups, if you look at them, look at the valency of the carbon here. If you look at the valency of carbon here, that means what? This carbon is already have formed 3 bonds. See, this COH group has formed 2 bonds with oxygen and 1 bond with the OH group. So valency of all this carbon is already 3. And they are left with only one valency. They are left with only one valency by which they can attach to the carbon chain. And that is why, and that is how they are present at the end of the chain. Okay. If you look at, these functional groups, their valency is not 3. Their valency sometimes is 1, sometimes is 2, but maybe 1 or 2 only. They are not beyond that. If you look at here, valency of your carbon. Valency of carbon in SO3H is what? It is also kind of a chain terminating group actually. Here valency of carbon is 2. Here valency of your carbon can be, it's 1 only. I mean, it can attach at anywhere in your carbon chain. Same here, same here. So in all of these cases, The non-chain terminating functional groups, they can be present at anywhere. They can be present at the mid of the chain. Okay, they can be present like here, OH, or your OH can also present at the start of the chain, no problem. But chain terminating functional group, they will always be present at the end of the chain. For example, the acetic acid, CH3, COH. Or you can have CH3, CH2, CH2, COH. See, you can't keep them at the mid of the chain. They will always be present at the end of the chain. And that is why we have different set of IUPAC rules. That is why we have a different set of IUPAC rules for non-chain terminating and chain terminating. Okay, so let's move on with it and let's see what are some of those rules. Okay, the very first rules for non-chain terminating functional group. Rules for the non-chain terminating functional group. Now, what are those rules? Firstly, parent chain. Now we all know, we had already known with all this factor. What factor? That you always need to select the longest possible chain. You always need to select the longest possible chain with maximum functional group and maximum unsaturation without caring, without caring whether it also donates the longest possible chain or not. So I had told you about this earlier also. See, whenever there is a functional group, even if it is a double bond, triple bond, those have also been included into this functional group category. Okay, so even if you have a double bond, triple bond, and these other functional groups, you always need to take them into consideration along with the maximum unsaturation. Now, while doing so, you might select the longest possible chain, or sometimes you may not. But you can't, you can't help. You just need to ignore it just for the sake of your functional group. Okay. Now let's look at here. If you look at this compound, and if I do the counting here, see the counting in red color. Now, if you start counting here, how would you go? You can go like this: 1, 2, 3, 4, 5. Okay, this is the longest chain now. But do we have a functional group in that? No, we don't have a functional group. Functional group is here. Okay, so you can go by this. You can go by this counting. So let's see the another counting. You can start counting from here. 1, 2, 3, 4. You can go like this, or you can also go like this: 1, 2, 3, 4. So the counting which I have shown you here is that only: 1, 2, 3, 4. Right? You can always go like that. Now you can go to either left hand side or right hand side. Doesn't matter. Doesn't matter. Why? Because number of carbon atoms are coming same in both the direction. Second possibility. What is the third possibility? In third possibility, you might, let me change the color again. You might start from here. 1, 2, 3, 4. In that also you are getting 4 carbon atoms, right? But in this counting, in this black colored counting, your functional group OH is coming onto the fourth carbon. And as far as this IUPAC rules are concerned, your functional group should come in as low counting as possible. And that is why the correct name would be where you are started counting from this first carbon where OH group is attached to. So 1, 2, 3, 4. At the second position, what have we attached here? Ethyl, right? So how would you name this? As 2-ethyl. You would name this as 2-ethyl, comma, butanol. 2-ethyl butanol. You can call this as butane 1 alt, but it's a OH group is present at the very first carbon, right? So that is why it's okay. Had it been attached to the second carbon, we would have said okay, butane 2 alt. But it is at the first position, so that's okay. That's fine. Okay. So moving ahead. Now, what is the second? the lowest number for the functional group. As I told you, your functional group should always have as low number as possible. So your numbering is done from that side of the chain, which gives the lowest locant to the principal functional group, followed by double and triple bond. Okay, let's take the example of this. Suppose you have a OH here. Okay, and yeah, and suppose if you have a double bond here like this. Now, how would you go? How would you go? Let's see. Suppose if I start counting from this carbon, 1, 2, 3, 4, 5, 6, 7, 8. We can go like that, okay? But in doing so, your functional group will be present at the sixth position. So it is not the lowest number. So this, this counting cannot be valid for this, okay? But you need to consider double bond. So what is the second option then? Second option is that you go by this. This is your first carbon. 1, 2, 3, 4, 5, 6. If you go here, you will get a 7, right? If you go above, you will get 7 and 8. And suppose if I made this chain further longer, I want to clarify one point. Suppose, see, I made it longer now. And suppose now 6, 7, 8, and 9. Now, if you go straight, you would have how many carbon atoms? You would have 9 carbon atoms. So that is the longest possible chain, and it has also included what? Your functional group. But it has omitted a double bond. So as I told you here, you need to consider double bond as well as triple bond. Firstly, you need to consider principal functional group. What is principal functional group here? See, if you consider double bond into the functional group, then you might say there are two functional groups here. Double bond also and hydroxyl group alcohol also. So in that, always remember, whenever you have any double bond, okay, and functional group, you should always give a priority to a functional group and then to a double or triple bond. So by that logic, OH having the lowest possible number is the first condition that we need to follow. Secondly, we also need to consider your alkene or double bond into the counting. And in doing so, you might not have a longest possible chain. Okay. So the other part becomes what? Other part then becomes the substituent. So this is your substituent now. And you go count like this: 1, 2, 3, 4, 5, 6, 7, 8. Right? So how would you name this now? See, at the sixth position, you got how many carbon atoms are there here? 1, 2, 3. It's a propyl, right? So how would you call that as? 6 propyl, right? 6 propyl. Total, you have 8 carbon atoms, right? So 6 propyl oct. Double bond is present at which position? Seventh position, right? So oct 7 in. Oct 7 in. And at the third position, you have what? Alcoholic functional group. So how would you write it? 6 propyl oct 7 in 3 all. That is how you should name it. 6 propyl oct 7 in 3 all. Okay. That is how you need to consider the main functional group, then double triple bonds. Okay. Moving ahead, I hope you must have understood this very well. Even if you have any doubt with this, you can ask me in the comment section. Okay, moving ahead. Now we had seen those rules for the non-chain terminating functional groups. Now we're gonna see the rules for chain terminating functional group. How chain terminating functional groups are being named. what are those chain terminating functional groups? One is aldehyde, CHO. How does it looks like? C double bond O H. Okay. And from this side, it is attached to your chain. Let's suppose your chain is now R. Similarly, COH. How does it looks like? C double bond O OH. On this side, it is attached to your R. Similarly, you have COOR. What is that? Ester. CONH2. What is that? Amide. COCl. What is that? Alkanoyl chloride and cyanide. Okay? All of these are present there. Whenever they are present, it is always given number 1. You should always give a number 1 to them. Now, let's understand that through the examples here. Look at here. This is your functional group. What? COH. So you start counting from that carbon. 1, 2, 3, 4. At the second position, what do you have? You have a substituent. So what do we call that as now? 2-methyl butane 1-oic acid. Let me give some another example now. See, now your functional group is rightly present at the middle of the chain. Now what do you do now? How would you name it? You start counting from this carbon now. 1, 2, and you can go to any direction. Whichever direction is having the longer chain, you need to go in that direction. Now, as far as this particular example is concerned, 1, 2, 3, 1, 2, 3, 4. So this is same. Even if you go to the left hand side, even if you go to the right hand side, it is one and the same thing. So because of that, this part is your substituent. Suppose if I go to the right hand side, that part becomes substituent. What is that substituent? Ethyl, right? Then what do we call that as? 2-ethyl. 2-ethyl butane 1-oic acid. That is what we name. That is how we name it, right? 2-ethyl alkane number at which COH is present. It is generally present at the first, obviously. So in fact, you don't need to put this one also there. So you can say 2-ethyl butane 1-oic acid. It doesn't matter. Okay. So yeah. Now if you look at here, here again it's straightforward. 1, 2, 3, 4, 5. Right? At the third position, you got a triple bond. So how would you write it? Pent 3 Y 1 ul. Now it's aldehyde, right? So how do you name it as now? Pent 3 1, and at 1 you got aldehyde. So pent wine ul. That is how you name these compounds. Okay. Chalo. Moving ahead with this now. Now, if a compound contains 2 or more like groups, what if compound have 2 or more like groups? Then what do? We add the numerical prefixes like di, tri, tetra, just like that. Look at here. So there are 3 OH groups here, all 3 carbons. Then what do? 1, 2, 3. Propane. This is the parent chain is what? Propane, right? And at all 3 positions, you got what? OL. So how do we call it? Propane 1, 2, 3 triol, right? Similarly, look at here. First carbon 1, 2, 3, 4, 5. So pentane 2, 4 dione. On stands for ketone. On stands for ketone. And di, why di? Because there are 2 C double bond groups. So that is how you write this compound's name nomenclature as. That is why you write pentane 2, 4 dione. Okay. So yeah, chalo. Moving ahead. So I hope you must have understood a lot of those things. Okay. How do we write it for the different functional groups? Be it your chain terminating, non-chain terminating. Okay. So moving ahead now. Let's see here. Now the name for your benzene as a substituent is what? Phenyl. Whenever your benzene is acting as a substituent, if your benzene, let's see here. See, this is the compound, and here suppose if I attach a chlorine here, then what do I call this as? Chlorobenzene, right? If you have a bromine here, bromobenzene, nitro group, nitrobenzene. But benzene is not a functional group as such. Suppose I have a benzene ring attached to a compound which is having a functional group like this, COH. Now what do you do now? Now you need to consider functional group as a primary focus. So in that case, what happened? The benzene ring becomes substituent. And whenever your benzene ring is substituent, it is called as phenyl. And it is present at second position here, right? Because this is your first position, no? 1, 2. So what do we call this as? 2-phenyl ethanoic acid, because there are 2 carbon atoms here in the acid. So we call that as ethanoic acid, right? And at the second position, you got the substituent. So what do you write for that then? What is the name? Phenyl, or I would say 2-phenyl ethanoic acid. Okay, now in case of phenyl, in case the phenyl ring is further substituted, in case the phenyl ring is further substituted, the carbon atoms of the ring directly attach to the parent chain in such a way that substituent on the ring gets the least possible number. So what do we mean by that? See, if you have more than one substituents, if you have more than one substituents on the benzene ring, then what do? You give that substituent as low number as possible. Let's look at this example. Now this is ester. This is what? Ester. And this is your straight chain, straight away. This is your straight chain. 1, 2, 3, 4. Right? This CH3 substituent. Now, at the third position of benzene ring, you got what? Nitro there. Now, if you start counting from this side, then you would have got 1, 2, 3, 4, 5. If you would have counted from this side, your carbon, your nitro would have got the fifth position. But according to IUPAC, it should have as low number as possible. And that is why you are counting it from the right hand side. Okay, so look at here. This carbon CH, it is attached to, this carbon is attached to 3 chlorine atom. It is basically CCl3, CH, and then it is attached to benzene ring like this. Okay, so your main functional group is what? CCl3, right? This is your first carbon, this is your second carbon. Then how do you name this as? 1, 1, 1 trichloro. 1, 1, 1 trichloro. 2, 2 diphenyl ethane, right? 1, 1, 1 trichloro. 2, 2 diphenyl ethane. That's how we name it. Okay. Similarly here. So this, you actually start counting from here. This is the first carbon. Okay. But basically, you know what happens in ester? This carbon, whatever carbon you have attached to this oxygen, this carbon is actually having a 0 number. It is actually 0. So it is like 0, 1, 2. Okay. Then you got what? 3. Like that. So that is how you actually name it. It is a different nomenclature. So for this ethyl, you do not give any naming. You just write it ethyl. You just write it ethyl. And counting starts from where? Counting starts from this carbon. 1, 2, and 3. Okay. So this is ethyl. Then what do we have at second position? Methyl, right? Ethyl to methyl. Then dash 2. At the second position, you got a benzene ring along with nitro group. And nitro group is attached at the third position of the benzene ring, right? So how do you name it? Ethyl to methyl dash 2 dash into bracket 3 nitrophenyl. 3 nitrophenyl propanoate. 1, 2, and 3. These are the three carbon doubly bonded oxygen and O. That is what? Propanoate. That is why you call it as ethyl 2 methyl dash 2 3 nitrophenyl propanoate. That's how you name these compounds. Okay. So moving ahead. Now, see, there are so many rules here, okay? So many rules. That is why I need to give you each and every example as far possible. If the organic molecule, if the organic molecule contains more than one similar complex, if the organic molecule contains more than one similar complex substituents, then the numerical prefixes such as di, tri, tetra, they are replaced by di is replaced by bis, tri is replaced by tris, and 4 is replaced or tetra is replaced by tetrakis. Okay. See, this kind of nomenclature has also been used in inorganic chemistry also. Okay. But that is not our point here. So let's see here. See, these are the two main carbon atoms. This is the functional group COH, first carbon. This is second carbon. Now these are what? These are substituents. So these are your substituents now. So now how do you name this substituent? Look at here. CH2, CH2OH. So hydroxy group is there, that's fine. And they are attached with the oxygen. Okay. And see, these hydroxy groups are there, but this substituent is complex. Okay. So that is why we need to put bis there. Bis means 2 only. You can also use bi for 2, right? And you can also use a di also. So earlier we were using di. Now whenever the complex substituent is there, instead of di we use the bi, but not bi, actually bis. Okay. So, and this is the main chain. This is your what? Main chain. So at the second position you got this. So you obviously at the second position, how do you name it? 2 comma 2, right? 2 comma 2 bis. 2 comma 2 bis, because there are two functional groups like that. So 2 comma 2 bis into bracket 2 hydroxy ethoxy. So this is 2, because now this is the substituent. Now to this substituent, at this second position OH group is attached, right? That is why you write 2 comma 2 bis dash into bracket 2 hydroxy ethoxy ethanoic acid. That is how you name them. Okay. So moving ahead. Now, how do you write the IUPAC name of these compounds now? So as I told you earlier, what do we do? This is the zero position, right? Zero position. This is the first position. 1, 2, 3, 4. You can go like this, or you can also go like 1, 2, 3, 4. As far as this case is concerned, you can go straight, you can come down, doesn't matter. Number of carbon atoms are going to be same only. And this methyl is at what? Zero position, right? So you just write it, methyl, right? Methyl. Now what do you do? Methyl, at the second position, you got what? Substituent, right? So methyl dash. Then what do you write? 2 methyl, sorry, not methyl, this is 2 ethyl, no? So methyl dash 2 ethyl, right? Methyl dash 2 ethyl, and what? Butanoate. This is the butanoate. So when you write the butanoate, they understand that it's an ester. And ester means what? C double bond O, O. And when you write this methyl there, they understand that this methyl is present, or it is attached to your oxygen. So your methyl is attached here. That is what they understood. So when you write the butanoate, what is mean by butanoate? CH3, CH2, CH2, C double bond O. This is called as butanoid. Basically alkanoid. Basically, this is called as alkanoid. So when you write the butanoid, they understand that this group is that. When you write methyl, that means methyl is attached to this oxygen. And for otherwise, other than that, you have already told that at the second position, ethyl group is there. Okay. So this is how the esters are actually nomenclated. Okay. Now, look at this compound. If you write the structure of it, C, CH3, C, CH3, C, CH3, and you have a OH here. So this is pretty much simple. It is not at all complicated. First carbon, second carbon, third carbon. Now I know that OH is present at the second carbon, but you can't just start counting at the middle of the chain, right? You need to go like this only. You can't start counting from here because OH is not a chain terminating functional group. Had it been a chain terminating functional group, we would have done that. But OH is a OH is a non-chain terminating functional group. So you go by like this only. 1, 2, 3. Methyl is your what? Substituent. Then how do you write it? 2 methyl, comma, propane. 2 methyl propane dash 2 all. 2 methyl propane dash 2 all. That's how you name it. Okay. Similarly, if you name this compound, it's a COH, right? So again, it's a chain terminating functional group now. So you go like this: 1, 2, 3, 4. This is your substituent, right? Present at the third position. So you write 3 methyl, comma, butanoic acid. You don't need to write the position of acid here because since it's a chain terminating functional group, it is going to be the first position only. Right? So yeah, moving ahead with that now. The rules, or you basically, I need to tell you the different prefixes that people use for naming these functional groups. Okay, so rules for IUPAC nomenclature of polyfunctional compounds. What are the nomenclatures for these polyfunctional compounds? Okay. So an organic compound, when an organic compound contains two or more different functional groups, when an organic compound contains two or more different functional groups, then one functional group is selected as the principal functional group, while the other group is treated as a substituent. Now that is obvious. Suppose, let me give you an example here. Suppose this is your compound. Here you have a COOH. Okay. And suppose you got chlorine here. Or I would rather say oxygen here, C double bond. Now there are two functional groups here. Now there are two functional groups. One is COH, another is ketone. So whom shall we give preference to? In that case, you need to give a preference to chain terminating functional group only. You always need to give preference to chain terminating functional group that will be considered as your principal functional group, and this oxo, or I would say ketonic group, would be treated as a substituent. Now in the IUPAC nomenclature, whenever you have a ketone there, that will be treated as it will be called as an oxo group. So how do you count? 1, 2, 3, 4, and 5. At the third position, you got what? Now this third carbon you are already considering, okay? That carbon is already into the consideration. But this oxygen is not. This doubly bonded oxygen that you have here is not. So this doubly bonded carbon is called as oxo. It is called as oxo. So how do you write? It is at the third position. So 3-oxo, comma, pentanoic acid. 3-oxo, Pentanoic acid. Pentanoic acid itself is a self-explanatory. It makes you understand that this carbon contains 5 carbon atom and functional group has been involved in that. Okay, so that's how you write 3-oxopentanoic acid. Okay, so let's see now what are those some of the prefixes, suffixes. I just wanted to tell you what happens when you get a two substituents. Sorry, what happens when you get a two functional groups? Then one will be considered as a principal functional group, other will be considered as a substituent. Okay, now COH. As far as COH is concerned, COH is the functional group which is having the highest. It is the functional group which is having the highest priority. Okay, so it will never come into prefix. That means it will never be treated as a substituent whenever it is in contact with the other functional group. Okay, so it will be a prefix only. Sorry, it will be no prefix here. And what is suffix? Oic acid. That we already know, right? Alkanoic acid. We had seen that. Now COH. It is called as carboxy. Now you might say, sir, you just said COH is not considered as a, what? It is not considered as a substituent. It is always a principal functional group. Yeah, you're right. But then there are some flaws. I wouldn't say flaws. There are some changes. There are some modifications. You will learn about those modifications as we move ahead. Okay. For now, let's understand that that is called as carboxy and suffix is carboxylic acid. That means what? What if you have 2 or 3 carboxylic acid group? Then what do you do? For example, for example, look at this. So you have a COH here. And what if you have a COH here also? Then what do? Then you need to consider one of them as a functional group, right? And then other will be considered as the substituent. You don't have any option there, right? So one of them will surely be a substituent. And in that case, you call them as prefix. For example, how would you count this now? See, you go like this: 1, 2, 3, 4. So 3 carboxy, what do we call 3 carboxy butanoic acid, or I would rather say 1, 2, 3, 4. No, 1, 3 dicarboxy carboxylic acid. Okay, you will understand more about them as we move ahead. Okay, now third functional group, SO3H, sulfonic acid. Here the prefixes that we use are sulfo. Sulfo are the prefixes and suffixes are sulfonic acid because they are acids, right? Lastly, sorry, not lastly, thirdly, anhydride. This group is called as anhydride, and from here it is attached to your R group. It is called as oic anhydride. Now you will see whenever we'll see the more and more examples, you will understand more about it. Okay, for the time being, it is called as oic anhydride, the suffix. There is no prefix here. Okay. Next, ester. Whenever you have a ester, how do you name it? We just saw there, right? You write alkyl first. Which alkyl? This alkyl. This alkyl. You call them as simply alkyl, and whatever R group, let's write that as R dash. Whatever R group you have on that side, that will be coming as alkanoate. Okay, so that is how you name it. So that's a ester. Or whenever it is attached with the carboxylate group, it will come into prefix as alkoxy, alkoxy carbonyl. Okay, whenever that example comes, I will tell you. Now acetyl halide. Acetyl halide, how do we name it? Oil halide. Remember, ethanoyl chloride, pentanoyl chloride, or bromide. Bromide is not actually existence, it is only chloride. Okay, but whenever it's a substituent, then what do? You call it as haloformyl. Haloformyl would be what? Haloformyl would be your prefix, and carbonyl halide would be your suffix there. Okay. Next, the amide. Amide, you write just amide, simply methenamide. Okay. But again, if you have a CONH2, then when it is substituent, it becomes carbamoyl. Carbamoyl, carboxamide. Okay. Similarly, cyanide. When you have a cyanide, you call it just nitrile. Okay. But whenever it's a substituent, what do you write? Cyano. That's the prefix. Cyano carbonitrile. Okay. So that is how you write all these functional group as their prefixes or their suffixes. Okay. Lastly, isocyanide. When you have a isocyanide, you write just the isonitrile. Just like for cyanide, you write the nitrile. For isocyanide, you write the isonitrile. That's it, the complication. But if it's a substituent, it will be called as isocyano or carbyl amino. Carbon, triply bonded carbon, carbyl, amino, nitrogen. Now, aldehyde. When you have a aldehyde there, you write it as an oxo. When it's a main functional group, you write it as L, ethanol, pentanol, like that. But if it's a substituent, you write it as an oxo, okay, or a formal. Formal is rather more used than the oxo because we use the oxo for the ketone also. Okay, sometimes you use the keto, sometimes you use the oxo. Doesn't matter. Okay, more or less it's one and the same thing. And one we add as a suffix that you already know, alkanon, pentanon, right? Lastly, alcohol. Alcohol, you add the alkane ol, butane ol, right? That's a suffix. What is the prefix? Obviously hydroxy. You can't call it oxy. I mean, if the oxygen comes first, you can pronounce it, right? So it's a hydroxy. When it's SH, it's a mercapto. If it's a main functional group, it will be called as thiol. But if it's a substituent, it will be mercapto. Similarly, NH2. If NH2 is a main functional group, you will call it as amine, alkanamine, ethanamine, like that. If it's a substituent, it will be called as amino. And lastly, ether. Ether is always a substituent. So it is always named as alkoxy only. Okay. So that is how all the nomenclature of different functional group is spanned. I know it's a bit of complicated, but in the next lecture, when we will see lots of examples, we'll see lots of examples of different functional groups, their complication, further complication, some exceptions. We need to spend maybe 1 or 2 lectures more into this. Then you will be understanding the depth of it. Okay. Chalo. Moving ahead. Now, numbering the, see, what I told you earlier is that principal functional group. If I ask you what is the principal chain order, the principal chain order is the very first is principal functional group. Principal functional group should come first, then the double bond. Double bond has a priority over the triple bond. And lastly, what? Substituents. Substituents should come lastly. The first priority is for the principal functional group, then double bond, triple bond, and lastly substituent. So basically it's a PDTS. Remember this order. PDTS. Principal functional group, double bond, then you have a triple bond, then you got what? Substituent. Okay. So let's see with the examples here. Look at here. Here you will start counting from here, right? 1, 2, 3, 4. At the third position, you got the ketonic group, right? So what do we call that as? 3-oxo, right? Butane 1 oic acid. Now this example I already gave you. Remember? See here, I already gave you 3-oxo pentanoic acid. Okay. Here it's not a pentanoic acid, it's a butanoic acid. But anyways, now again, see now this is the ketonic group, this is aldehydic group. Now, between aldehydic group and ketonic group, you need to give priority to aldehydic group. Now, this is not like unfair with the ketone, but it is the rule with the IUPAC system. You need to give priority to aldehyde. So 1, 2, 3, 4, and 5. So at the fourth position, you got the ketonic group again. So 4-oxo pentane bunyl. Okay, just like that. Look at here. Here again, COH is the main functional group. So you start counting from there only. 1, 2, 3. Okay. Then you have a ketonic group here. And lastly, you have what? Aldehyde group here. Now that's okay. You got a aldehyde group also. You got a ketonic group also. But let me give you one more thing. See, this aldehyde is also terminal functional group. COH is also same terminal functional group. But as per our IUPAC nomenclature, we give priority to what? Carboxylic acid only. So you start counting from here only. 1, 2, 3, 4, 5, 6. Okay. Now, even if aldehyde comes before the priority of your ketonic group, you can write 6 first. So you can write 3, 6 dioxo. 3, 6 dioxo hexanoic acid. When you write 3, 6 dioxo, that means oxo group is present at third position. So when it is present at a third position and you have a 6 carbon atom, that means it is surely ketonic group. It is a self-explanatory. Secondly, when you write a 6, 3, 6 dioxo and hexanoic acid, that means overall 6 carbon atoms are there only. And oxo group is present at third as well as sixth position. If it is at third position, it's a ketonic obviously. But if the same oxo is at the sixth position, that means it can't be ketonic group, right? Ketonic group is not chain terminating. That means at the sixth position, it must be 6 double bond O, sorry, C double bond O H. Okay. So it's a kind of a self-explanatory only. So that is how you write 3, 6 dioxohexanoic acid, or there is an option. You can just omit this CHO group. You can just omit it. You don't consider that into the chain. Okay. You consider this whole CHO group as a substituent. You consider the whole CHO group as substituent. In that, you count till fifth only. Then what do you write this CHO as? Formyl. And it is positioned or it is attached at the fifth carbon, right? So you write at 5-formyl, 5-formyl 3-oxo pentanoic, just like that. Okay, that is how you actually name it. So moving ahead. Now this is the point I wanted to tell you. Now what if there are more than one, same, if there are more than one same chain terminating groups, there are more than one same chain terminating groups are present, then principal chain is selected including the functional groups. Numbering is done from that side which gives the lowest locant to unsaturation substituent. Now unsaturation substituent, if it is present there, okay. For example, look at here. This is straightforward. 1, 2, 3, 4. At the first you have a COH. At the fourth you have a COH. Straightforward. 4 carbon. What do we write? Butane 1, 4 dioic acid. Remember, we named carboxylic acid as oic acid. Now there are 2 carboxylic acid. So what do we write? Dioic acid. Di means 2, right? Now here, I gave you such example before also, but that case, it wasn't present at the end of the chain. Here it's present right at the end of the chain. Okay. You will see more such examples, then you will understand it with the more detail. Okay. Now, look at here. Cyano group, cyano group. So both of them are obviously functional group. You need to consider them. So you go like this: 1, 2, 3, 4, 5. At the second, you got substituent, right? So it's a 2-methyl, obviously. 5 carbon atom including cyanide. 2-methyl pentane dinitrile, because when the carbon is attached like this, you are considering this into the counting, right? You are not considering nitrogen there. So you call this part as nitrile. And if this part is twice, then what do we call it as? Dinitrile. right? So you need to consider this carbon also to the counting. So 2-methyl pentane dinitrile. That's how you name this. Now lastly, look at this compound. Cyano group is attached here. So obviously cyano is the functional group. You need to consider it only. Then how do you do? You start counting from that only. So 1, 2, 3, 4, 5. You can go straight also, but you will get 6 carbon atom only. But if you come down 5, 6, 7 carbon atom, longest chain along with the functional group in consideration, this will be your substituent, right? At the second you got the, not second, at the third you got the substituent. Then how would you name it? 3-ethyl, right? Substituent has 2 carbon atoms. 3-ethyl and one more. You got the methyl also, right? At the fifth position. So 3-ethyl dash 5-methyl. After that, how do you name it? It's a 7 carbon atom including this cyanide. So 3-ethyl 5-methyl dash. I will write it down here now. Okay. 3-ethyl because otherwise it will go into my face. 3-ethyl 5-methyl heptane. Heptane nitrile. Now I don't need to mention what is the position of a cyanide there. When I say nitrile, it's a chain terminating functional group. So it should be present at the first carbon only. So 3-ethyl 5-methyl heptane nitrile. That is how you name this functional group. Okay. Sure. Moving ahead. Now, now we have arrived to the discussion of benzene ring IUPAC nomenclature. IUPAC nomenclature of aromatic nucleus. Aromatic nucleus means what? Benzene ring. Basically, I am talking about benzene ring. Okay. So, nuclear substituted. What is mean by nuclear substituted here? You will understand what I mean to say by that. See, the functional group is directly attached to the benzene ring in the IUPAC system. They are named as derivative of benzene. For example, if you got a CHO group here, then what do we call? CHO group is aldehyde, right? And this is benzene. So it will be called as derivative of benzene then, benzaldehyde. It will be called as benzaldehyde. If you have a benzene ring, a COH, what do we call that as? Benzanoic acid. So basically they will be treated as a derivative of the benzene. Okay. Now that is when the functional group is directly attached to the benzene ring in the IUPAC system. Okay. Now the position of the substituent in a di-substituted benzene are they indicated by ortho for first position, very first position. Second, it's a meta, right? And para. We know this position, right? For 1 and 4. We all know this position. I have told you earlier also in GOC also and in a aromaticity also. So we had seen that. Okay. For let's see those examples now. See, let me tell you here. See, this is your main functional group. Suppose this is your main functional group. Let's write it as G. Suppose main functional group. So if your substituent, let's write substituent as S. If it is present at S, then what do you write? It as ortho. Okay, let me give you an example only. Direct example. So this is COH. If your OH is present here, what do we write? Orthohydroxy benzanoic acid. If your OH is present at here, what do we write? Meta-hydroxy benzanoic acid. Because this is the third position now. This is the first 1, 2, 3. 1, 2. And if it is present at the fourth position here, then what do we write? So 1, 2, 3, 4. 4 hydroxy benzanoic acid, just like that. Or Yes, Kirtidhar, you can ask me if you have any doubt. Yes, yes, Kirtidhar, and there, ask me. So this is the, you can call it as ortho, meta, para, no matter. It's okay. But you can also write this numbering. See, one, two. So what do we write? 2 hydroxy benzenoic acid. Or here, one, two, three. 3 hydroxy benzenoic acid. Similarly here, 4 hydroxy benzenoic acid. And then nuclear. Okay. Kirti, the nuclear means what? See, if you talk about the nucleus, what is mean by nucleus? Something which is present at the center. Something which is present at the center is called as nucleus. Okay. For example, you know that every cell, every animal or plant cell has a nucleus. So where do we have a nucleus? At the center, right? Similarly, in the structure of atom, what do we have at the center? Nucleus. That nucleus has protons and neutrons, right? Now that proton neutron together is called as the nuclear part. So here, what I'm saying, aromatic nucleus means what? Your benzene ring is at the center of the naming. Your benzene ring is at the center of naming. That is why I'm saying aromatic nucleus. Got it? Okay. So very good. So moving ahead. Now, side chain substituent. What if your benzene ring is side chain substituent? What is mean by that? Okay. The functional group is present in the side chain of the benzene ring. In the IUPAC system, they are usually named as phenyl derivative of the corresponding aliphatic compounds. Okay. Now, once we see the example, you will understand it with the more detail. Okay. So, aromatic hydrocarbons. For example, what? Arenes. Benzene rings are also called as arenes. Okay. So, these aromatic hydrocarbons which contain both aliphatic and aromatic units are called arenes. And again, there are two types. Hydrocarbon containing one ring only. Let's see. Look at here. Now, this hydrocarbon contains just the one ring. What is that? Benzene ring. At the first position, you got the methyl. Second position, you got a methyl. Then what do we call this as? 1, 2 dimethyl benzene. Similarly here, 1, 2, 3. 1, 3 dimethyl benzene. Similarly here, 1, 2, 3, 4. 1, 4 dimethyl benzene or isopropyl benzene. This is the isopropyl part, right? We had seen that earlier. Here the chain is present or benzene ring is present. So this part is called as isopropyl. So this is isopropyl benzene. Isopropyl benzene also has a common name which is very much famous. It's called as cumene. Okay. Now this is, see, when you got one benzene ring, and methyl, it is called as xylene. Xylene is the name for it. Now when you are writing O-xylene, no, that means at ortho you got one more methyl. And ortho means what? Second position. So orthoxylene, that means 1, 2, right? Ortho position, no. Metaxylene, that means 1, 3. Paraxylene, 1, 4. That is what I was saying there earlier. Okay, so that's how the nomenclature of these groups is all about. Okay, so moving ahead. Now look at here. Now ethynyl benzene. Now here, this is your what? This is ethene, right? Now this ethene is also substitute. When alkene is substitute, you call what? Alkyl. So similarly, when your ethene is substituent, what do you write it? Ethynyl. Ethynyl benzene. And it also has a very famous common name, that is styrene. Right? Similarly here, 3-propenyl benzene. Now here, this is also called as allyl benzene. Now let me tell you what is meant by allyl. See, you got a doubly bonded carbon like this, CH2, C, just a sec, yeah, CH, yeah, CH. Now this position, This position of carbon just outside the W bonded carbon, this is called as allyl. This is called as allyl. And you can see here, this is the first carbon, second carbon, third carbon, which is just outside the benzene ring. Sorry, just outside the W bonded carbon. So that carbon benzene ring is that. That is why it is also called as allyl benzene. Okay. Similarly here, this is C triple bond C H. So this is ethyne, right? Now you replace this hydrogen by what? Benzene ring. So that is, what do we call that as? Ethynyl benzene, right? Or you can also call that as phenylacetylene. Again, that's a common name. Okay. Similarly here, triple bond 1, 2, 3. At the third position, you got a benzene. So 3-propynyl benzene. Okay. That is how all of this nomenclature is all about. Now there is a pretty much so much into this nomenclature of the benzene ring. Then you will also have a 4-member ring, 5-member ring. Then you have what do we call them as breach compound, spiro compound. Okay, that is what we're gonna see into the next lecture. So till here, that is how you name the aromatic nucleus along with the different functional groups naming both terminating and non-chain terminating. I hope you must have find this pretty much helpful. You must have liked this also. If you really do, please like this video, comment on it, subscribe to Practically Live on YouTube. You can also download our app from a Google Play Store or from Apple Store, right? And from there, you can log into it. You can check a different courses. We have a courses in a Vedic maths, coding, chess, robotics. Recently, we started a course in a Python also. Okay, and recently we have added a very interesting feature in our app, that is scan anything. If you scan a different object, you will gather information about it. That is what we have recently added into that. Okay, so I hope you must have found this really helpful. And if you really want to explore all those interesting features, you need to download our app. Okay, so that's it for today from my side. Bye bye everyone. Good night.